Hi guys, welcome everyone. In this question it says Q1 charge, which is 5 microcoulomb, it's at the origin, and second charge Q2, 3 microcoulomb, it's at the x-axis and 0.8 meter away from the origin. Find the electric field at a point on the y-axis 0.5 meter from the origin. So if we draw the x and y-axis, so this is the origin, and the Q1 is here, and Q2 it's here, 0.8 meter, and it's asking electric field at the point which is above the origin, 0.5 meter. And charge of the Q1, it is the 5 microcoulomb times 10 to negative 6. Charge of the Q2, it is negative 3 microcoulomb, 10 to negative 6. And then now at this point, which is question about it, the electric field because of the Q1, it is away to it because it's charge positive, and because of the Q2, electric field towards the charge. If you remember, positive charge sending electric field lines, and the negative charge, it is collecting electric field lines because of that. So we can say this is the first electric field and this is the second electric field because of the second charge. And here, as you see, the electric fields, the E1 lie in the y-axis, but E2 it is not. So we have to calculate the component of the E2. To calculate the component of the E2, we need to find angle here. How can we calculate that angle? By the inverse tangent formula. Tangent inverse, it is opposite, which is opposite 0.8 over adjacent, which is 0.5. So the angle gonna be 58 degree. So this angle is the 58 degree first of all. And I will use the formula E equal for the electric field K times Q over R square. So I need the distance. So the distance between Q1 and the point, it is 0.5 meter, but the Q2 and the given point, it is unknown. By using Pythagorean Theorem, I can calculate it. Let's say this is the R, so R square will be equal 0.5 square plus 0.8 squared. So if you take root of both sides, R will be 0.94 meter. And then we have to calculate the E1 and E2. What is the E1? E1 is K times Q over R square. K 9 times 10 to 9. Multiply by the, for the E1 we will use the Q1. 5 times 10 to negative 6. Over the distance between them, 0.5. That will be square. And the result of the E1 gonna be 1.8 times 10 to 5, the unit Newton per coulomb. E2 will be again 9 times 10 to 9. Charge of the Q2, it is 3 times 10 to negative 6. Over the distance between them, as we calculate this, 0.94 squared. So E2 will be 3.03 times 10 to 4 Newton per coulomb. And then we have to calculate the component of the E2. We have to calculate X component and the Y component of the E2. E2x is x for this angle, it is opposite, so it will be sine 3.03 times 10 to 4 times sine 58, and that will be equal 2.57 times 10 to 4 Newton per coulomb, and E2y, it will be 3.03 times 10 to 4 times cosine 58, so it's gonna be 1.61 times 10 to 4. So this is the E1, this is the E2x, and this is the E2y. So we have to find the net electric field at the y component and at the x component, but at the x component we have only one, so it is directly x component. For the y component, that means between E1 and E2y, we have to do operation. And let's check the E1. It is 1.8 times 10 to 5, and E2y is 1.61 times 10 to 4. So E1 is greater. So for the EY, we will do subtraction, E1 minus E2y. So E1 is 1.8 times 10 to 5 minus E2y is 1.61 times 10 to 4. If you use calculator, you can solve this one easily. It will be 1.64 times 10 to 5 Newton per coulomb. So to calculate the net electric field or total electric field, we have to use Pythagorean Theorem. Ex squared plus Ey squared. So Ex is the E2x, so it is 2.57 times 10 to 4 square plus Ey is the 1.64 times 10 to 5 square it will be, so this will be under root. So E total gonna be 1.66 times 10 to 5 Newton per coulomb, and electric field is a vectorial quantity, so we have to calculate also its direction. So theta will be tangent inverse 1.64 times 10 to 5 over 2.57 times 10 to 4. That means y over x. So the angle gonna be 81.1 degree. And what is the direction of the angle? It will be above positive x axis. Thanks for listening.